So today we're looking at the NZXT H700i, but more specifically this module that comes packed with it. This is NZXT's smart device, and we're going to evaluate whether or not something like this has a place in the case industry, or whether it's something that you should probably skip. Now, when it released with the H700i, H400i, and the H200i, reviewers had mixed feelings on what they could say about the smart device. At the end of the day, it's a circuit board which allows 3 fans to be connected to it in addition to an RGB strip, and that communicates with the CAM software. But when it comes to machine learning and adaptive noise reduction, I am intrigued to what's actually going on here. Before we delve into the smart device though, let's take a quick tour around the case, because in my opinion, the H700i is one of the best all-round cases on the market right now. Design-wise, I definitely do like the aesthetic here, with perforation lining the perimeter of the case for improved access to airflow. We find a similar theme on the power supply shroud as well, and you'll also find modular SSD brackets here too. Cable management is thoughtful. There's tempered glass here as you would expect. We've got 3 intake fans at the front and 1 at the rear running as an exhaust. An RGB strip is pre-installed at the top of the case, which looks nice, and there's also another one included in the box. And lastly, this interior bracket, which can be used to mount a reservoir if you're going to do a custom loop. But more than anything, this just gives the H700i a unique aesthetic. All this for a rather steep $199 US, but to be fair, you are getting a lot for your money, and the build quality on this case is definitely among the best I've ever seen, if that helps. Now, the reason that I'm interested in this smart hub is that something like this would be very easy to hard code based on fan RPM and hardware temperatures as the only inputs. For example, a program to do this would test a certain number of fan RPMs and then populate a lookup table with both the CPU temperature and the GPU temperature for each test. Then, with the table complete, the program could generate a fan curve based off of the results. For example, if higher fan RPM does not result in greater temperature reduction, then assigning appropriate max. And if dropping the fan RPM below a certain amount causes the CPU or GPU to idle too warm, then assigning an appropriate minimum. But that's not what's going on here. Well, at least I hope not. Since this device claims to provide adaptive noise reduction, it needs to receive noise as an input. So pulling the smart hub apart, there's one device that I'm looking for on the PCB in particular, and that's a microphone. We've got some inductors here in the middle, some capacitors beside those, a few resistors where need be, the ARM Cortex M3 processor in the middle here, which handles the RGB lighting and communicates via the USB port, and finally, the part that we're looking for, the Silicon MEMS microphone. So there is indeed a microphone on the board, which means that it does have the potential to accept sound as an input, and so far things are looking good. Of course though, this microphone could be here just for good measure, and we will be testing a variety of inputs to see how well it's received on the software and what the output is. Alright, some interesting testing to do, but before that, the build. Alright, so here's our standard test system with a Ryzen 5 1600 running with the stock cooler on a B350 motherboard and also a GTX 1060. A fairly balanced configuration, I'd say, which is definitely important with this sort of test. Hopefully it helps with more accurate results. The first thing we need to do is boot up the CAM software and get everything installed and ready to go. Initialization is pretty simple here, so let's take a look at what we're working with. The CPU and GPU are sitting at a fairly nice idle temperature here, only a few degrees over ambient, since this was a completely cold boot. But let's jump over to the Smart Device tab to see what's required. Let's start with step 1, which is called Preset. Fairly vague, but basically the CAM software will monitor and log the CPU and GPU temperatures first at idle and then when a game's running. The idea in this step is to get a starting point for the base system temps and noise levels without making any adjustments to the fan RPM. This is when I began to feel the limitations of the program at hand. Also, the microphone is working and is what's being used to monitor the noise levels for the program. Here, tapping on the glass and the case caused momentary spikes in noise levels, which was good to see, but we'll discuss the issues with this in just a minute. Next was step 2, so with the base testing complete, the next step manipulates the case fan RPM and logs the CPU and GPU temps while they're under a bit of load. Here the fans would ramp up and slow down several times, and I'm guessing this was to get as many data points as possible, and in other words, learn the system as best as it could. By the way, both this step and the previous step took at least 20 minutes each. Now before we could move on to step 3, I did have to wait a little bit as the program was doing some analysis for the fan RPM, system temps and noise in an attempt to configure an optimized adaptive fan profile, which would then be tested in step 3. So essentially step 3 is the same as step 1 in terms of what tasks are involved. However, we're now testing the new fan profile that has been configured by the system. So again, booting up a game and giving the system some load for a bit, and 20 minutes later and the testing is all finished and we have some results. Okay, so the results are fairly underwhelming. Here we've got 3 columns, and for some reason I can only see changes made to idle and not when the system is at load. It'd be really cool if I got to see the new fan profile graphed against the old one. Anyway, it's saying that the new fan profile is giving us 0.3 dB less in terms of noise when compared to the original profile. Fan 1 RPM has been increased by 16 RPM and fan 3 has been decreased by 635 RPM, which means it's not actually spinning at all when at idle. It's also saying that CPU and GPU load have been decreased to just 1% with this adaptive profile, which makes no sense at all. So aside from the results, there's a few issues and limitations when it comes to this program. Basically, it's trying to micromanage and adjust variables like system temperature and noise levels that honestly have quite a lot of variance in the real world. For example, when the smart device is monitoring noise inside the system, there's no way to block out the sound of my air conditioning switching on and off, me typing on my mechanical keyboard, talking, the TV in the background, even me getting out of my chair would cause a large variance in the noise picked up by the device, and so the idea of carefully trying to monitor system noise levels is fairly inaccurate and unreliable. Next, there's the ambient room temperature, as the smart device has no idea what the temperature is like outside of the system. Again, it's quite possible that I could have opened a window or my fridge, for example, and this could drastically affect the outcome of the program. And then there's the conversation of what loads we should load up during the testing phase. I opened up Witcher 3, but sometimes I was in games, or sometimes I was in a menu, or maybe even a cutscene. So CPU and GPU utilization and temperature here changes drastically also, and so you have to wonder if this has an effect on the outcome as well. Now, I have no doubt that this program would work in a lab environment where noise and ambient room temperatures can be controlled, and the program can just do its thing without having to account for conditions like if there's constant spikes in noise levels or if there's been a 3-degree reduction in temperature. And so here's what I would do if I was NZXT and I actually cared about what the outcome was of this device, because I'm pretty sure they understand its limitations, but it's cool marketing material at the end of the day, and they get to say things like this.
Adaptive noise reduction optimizes your build's acoustics through machine learning and ideal fan settings.
So for a version 2.0, I would suggest to get rid of noise as a tested variable completely and throw adaptive noise reduction out of the window. At the end of the day, we can achieve adaptive noise reduction solely by testing CPU and GPU temperature and also fan RPM. Essentially, the new program in CAM would go through the same testing as it did in step 2, testing the system both at idle and during a stress test amongst a range of fan RPMs in the system. The difference here would be that the system wouldn't base its outcome on reducing noise, but rather improving system temperatures at the most reasonable fan RPM that it could. This would be adaptive temperature reduction, and sure, noise could be something that is monitored and improved, but it shouldn't affect the results. And it's still machine learning as well, since you could get different results based off of what hardware is being used in the system, how many fans are being used, and even what season you're in, for example, whether you're in summer or winter. That would be really cool, but this in its current state is honestly just a complete mess, and I hope NZXT actually do something useful with this technology moving forward, rather than just use it for marketing hype and cool slogans. As always guys, I'm interested to see what you guys have to say about the smart device from NZXT and whether or not you think this has a place in the case industry. Also, if you have either the H200i, the 400i, or the 700i like the one behind me, let me know what your results have been with the smart device, and if you've actually got some good results from it, I'd love to hear from you down below. Thank you all so much for watching, and I will see you all in the next one.